Okay, so lesson 3.3, solving systems of inequalities. That's not supposed to say using elimination there. That's in the wrong spot. So, what is the difference between yesterday and today? Yesterday was solving systems of equations. Today's solving systems of inequalities. What's going to be the overall difference? The inequality sign, which means we're going to be shading, yes? Okay, yesterday you were looking for where the two lines would intersect. Okay, so we were looking for that intersection point yesterday. Today, we're not looking for where the two lines intersect, but we're looking for where the shadings intersect. Okay, so as we look at this first example, now, what is the solution of the system? And you'll notice it says g plus m greater than or equal to 6, 5g plus 2m less than or equal to 20. Can we work with g's and m's if we want to? Yes. What if you don't like those g's and m's there? Can you change those over to x and y for your own personal benefit? Yes. So, and I'm going to do that for the graphing purposes, but just kind of you see variables like that and you're more comfortable working with x's and y's, then by all means, do so. So if I look at this first one, I'm going to call it x plus y greater than or equal to 6. Okay. You teach me. What do I have to do here? Subtract x. What's the point of subtracting x?
Move it over.
Okay. We want this to be what form? Y equals mx plus b. So if I'm trying to get y by itself, subtract the x. So now I have y greater than or equal to. Okay, yeah. Negative x plus 6 is the preferred option here. And now we have that in our y equals mx plus b form, correct? So let's go graph it while we're here. If that's in y equals mx plus b form, where does that first dot go? At 6, because our y-intercept is 6. That 6 is going to go up 6, since it's a positive 6. Remember, this is horizontal is x-axis, vertical is y-axis. Where do I go from that 6? Okay, so she suggested down 1, over 1. Which way is over 1? Okay, I kind of always assume if you don't specify to me, over 1 is going to be right 1, but just specify. So if you think of this slope as negative 1, negative 1 over 1 can be written. And so that is down 1, over 1. Down 1, right 1. If you prefer, you could also reverse it, though, and go up 1, left 1. Up 1, left 1, because that is the same thing. Now, today, am I looking for where my lines cross? No. Not precisely. So do you have to have as many dots? No. Not in my opinion. Yesterday, I went overboard. I went dot crazy. Some of you guys loved it. Some of you guys hated it. Today, I'm going to put some, but I don't feel like I have to have as many. Okay. Now, Eli, did I get your question in there along the way? Okay, what's your question?
So, when you have a fraction for a slope,
Yes.
it's negative in the always would seem to go like down 1 over 1, like to the right.
You can do it one of two ways. We can put the negative with the top, which is what Peyton did here. And so she took us down 1, right 1. The other option, depending on your graph, if it would be easier to go up, you can reverse it and put the negative in the denominator and go up 1, left 1. It can be either or. It's just not both. Okay. We good up to this point? Okay. Did you guys already draw your line? Because what should I be asking myself right now?
Solid.
Good. Solid or dashed? And is it a solid or dashed line?
Solid.
Solid line because
It's not equal.
it's equal to. It has that little line underneath it saying equal to, so that means we make a solid line. And some of you are saying, oof, good, because I drew the line without thinking.
Yeah. I did some with it.
Now, Notice, I would encourage you, make your line the length of the graph. Don't make it a real short line. Make it the length of the graph, because what is my next step here?
You want to cross them.
So, it was a solid line because it was greater than or equal to. And where am I going to shade? She says above. Do we agree? Why do we shade above? Because it's greater than. So we want where y values are greater than this line. Now, my recommendation, don't go overboard on your shading here. Okay? I would say a nice light shading. Harder for me to do in pen than it is, but a nice light shading. I want to be able to see where you've shaded, but we're not done. Does that make sense what I'm saying there? Again, it's harder for me to do a light shading when I'm using ink pen, but I'll change colors, so. And notice, I shaded that whole upper corner, didn't I? I didn't just shade right along the line, but I shaded that whole upper corner of the graph. So far, so good. Okay. Second part. I'm going to write this equation as 5x plus 2y less than or equal to 20. Well, that didn't make things much better. Okay, what do I do? Okay, this time we're subtracting the 5x because I want it to be y equals mx plus b. So if it's positive 5x, subtract 5x. 2y less than or equal to. I'm going to switch that around as negative 5x plus 20 to get the y by itself. Divide by 2. And y is less than or equal to negative 5 halves x plus 10. Okay. Where do I start in this one? Up 10. How does this slope work? Okay. The negative can go with the 5 or the 2. So down 5, right 2. Up 5, left 2 doesn't really do anything for me here, does it? Kind of takes me off the graph. So down 5, 3, right 2. I am going to do at least one more dot, just to make sure my line is kind of straight. How are you connecting those dots? Solid again, because it is equal to. And what's my other question? Where do we want to shade? This one is a less than symbol. So because it is a less than symbol, we are shading below. Where is below on this line? Happens to kind of be on the left because of the negative slope. Okay. Again, don't go too crazy with your shading. Okay. where is my solution?
The area where they're both shaded.
Okay, the area where they're both shaded. Okay, in this particular problem, that little V up top. Okay. What I would ask or encourage you to do is when you are doing this on paper and pencil, obviously it's a little bit different in Math Excel, right? But when you do this on paper and pencil for me, make it so I can tell for sure you understand where that overlapping area is. Okay? If that means just, my suggestion is take whatever you're shading with and just shade a little darker on that case. Okay? Obviously, if you're using different colors, you can do something. But if you're just using pencil, just, shade a little darker. Just something so that when I grade this, I can tell, okay, they understand that their solution is that overlapping little triangle. Okay, questions? Because again, that was Algebra 1 review, yes? And we've done stuff like this. It's just putting it all together. Yes, Carter?
We would have to put this in. I remember, in Math Excel yesterday, we had to put, the point where we put 2 lines met and, a number.
Oh, you had to write the ordered pair to say your answer.
Right. There's no way to, write that.
No. The ordered pair here of where they intersect means nothing here.
Okay.
Okay, I'm not concerned about the intersection point. It'll be the graphing. And so, I forget exactly how Math Excel does it, but you'll be all about the shading.
Okay.
Now, it could be you guys might want to, sketch some of these on paper and pencil. It could be, I'm trying to remember, Math Excel might not let you do how I shaded this whole side and this whole side and then I did the overlapping. There's always a possibility when you do this online that they only will want you to do this shading here. Okay? So if they only allow you to do the overlapping shading, you would just pick this section right here. Those two would be blank. Okay? Okay. We're not going to do all of these, but I do want to just practice to make sure we're on the same, all on the same boat here. So let's go ahead and do problem 2, and then we're going to flip over and do something on the back. I think this is one. Yeah, this works. Okay, so you got your review in. You know what you're doing. I think some of you have started without me. Not a bad thing. Okay, first equation. X plus y greater than 4. What did you do for that first step? Okay, subtract the x. So I'm going to get y by itself. So y greater than, I could say 4 minus x, but I personally prefer negative x plus 4. How do I graph this?
Put it on the floor.
Okay. First dot on the 4, y-intercept, so I'm going to go up 4. What about my slope? Okay. It's a negative 1 slope, so you can go down 1, right 1, down 1, right 1, or if you prefer, you can put the negative on the bottom and go up 1, left 1, up 1, left 1. Notice, you guys know which way a negative slope faces, right? You know that negative slope angles down, and that's what this line is doing. Okay? Now what? This is a dotted. That would be a combination of dashed and dotted. Okay? So, this is a dashed or dotted line is what I was trying to say. Or if you prefer the combination, it's a dotted line. Making up words here. Okay. There's my dashed line. Shading. There's a greater than sign. And greater than tells me to shade above. Where's above on this line? That upper right corner again. guess I'm slightly off the screen there. However, you can see what you need to see. Okay. Y greater than or equal to negative 1/2 x plus 1. What do I have to do first? In terms of solving, it's good, right? They actually gave us one that's y equals mx plus b. So, jump right into the graphing, and 1 tells me up 1. What are you doing for your slope? Down 1 over 2 seems to be most popular. So it's a negative 1, positive 2. Negative 1, positive 2. If you prefer, the other option is to go up 1, left 2. What would you like to do?
You want a solid line.
Why is Caden saying solid? Because it's equal to. Good. So, plain old normal everyday solid line. Where's my shading? Okay. Greater than says above. So where is above this line? Well, it's above. It's a pretty obvious above, isn't it? Okay. In that disaster of shading. Sorry, I always feel like mine looks horrible with the ink pen, but if I do this in pencil, you guys can't really see, so. Where's my answer? Where's my solution?
It's mostly
In the upper right corner.
Okay. So on mine, it's above my blue line, except right here where my maroon line goes through. So again, give me some way to know that you understand that's where the solution is. Again, a little bit darker shading is what works there. We could keep continuing with that third one, but I feel like it's overkill.
Shading is really not.
Yeah. Okay. Change things up on the back, which is why I wanted to get to the back side.
Oh, great.
What is the solution of the system? So we're still doing the same thing, but as I said, change it up. Y less than or equal to 3 and y greater than or equal to absolute value of x minus 1.
Vertical line.
Maybe. Let's start with y less than or equal to 3. What line are we graphing here? We talked about this yesterday. I mentioned this, right? And you had to graph one of these in homework. We're graphing the line, that says y equals 3. So how do we graph a line that is y equals 3? Okay, we're going to put it on the 3 on the y-axis, right? Yeah. So on the 0, 3. And what kind of line do we draw through that 0, 3? Horizontal line. Okay, so this is a horizontal line through the point 0, 3. So I'm going to go 3 on the y-axis, since it says y equals 3. I'm going to do a horizontal line. So if you want points, you can think of it as 0, 3, 1, 3, 2, 3, 3, 3. Those are some points for you if you want points. Same two questions as the questions on the front side, and that is solid or dashed line? It's equal to, so this is going to be a solid line. And what else?
Shade below.
Above or below? This is a less than. So I'm shading below. Where's my below? Well, pretty obvious below here, isn't it? Again, don't go crazy dark because we're not done, right? Okay, got that one done? Y greater than or equal to absolute value of x minus 1. How do I graph this? What are you thinking, Eli?
That's the value of y-intercept is positive 1.
You have to go right.
Not the y-intercept.
So x, but I don't know anymore.
Okay. So, first of all, it's absolute value. Before I go into that, which direction we're going to move this, what kind of graph does absolute value give me? A V, yes? Okay. So, just because that was last chapter, can we forget what we did last chapter? No, it builds, right? So at this point, I expect, okay, I've taught absolute value graphs. I expect you to know how to do those, right? Now, okay, so the remembering is, this is what Eli was trying to remember which way. This is in the parentheses, yes? So he remembers it goes the opposite the way. But in the absolute value, it's opposite the way. But which ways? Left or right. Okay? If it was at the end, there's your up or down. So this one, since it's minus 1 here, we're going to shift right 1. So, you guys can start graphing if you want. I'm going to write down a couple of notes. So first of all, it's an absolute value, V. There's my reminder there. And we're going to shift 1 to the right, or I should say translate. So if normally my vertex is at 0, 0, that means my vertex is now at 1, 0. It's hard to see that dot, sorry. And then how do I draw the sides of the V?
With a solid line.
Yeah, there's no other number out front of my absolute value other than the invisible 1. So that means we do have, you could call it a slope of 1. So up 1, over 1. Rise 1, run 1. You can do this on both sides. The left side just goes the negative direction. Okay. How are you connecting this V? This is going to be a solid V with what kind of shading? Greater than says above. So solid V. Shading above, which in this particular case, above ends up putting us in the V. Did you show me your solution? Where are you showing me your solution is at? Okay, in that little triangular section here. You got a little triangular solution. Okay, so this is new technically. You haven't done inequalities with absolute value in terms of like those, you know, two of them together. Can we handle that stuff?
Yeah.
Okay. It's one of those things. I haven't taught you anything really truly new today. We've just put all of our old stuff together. Huh?
Unless you're me and you're just too young to remember the absolute value means.
It's just a matter of lots of practice. practicing and getting it committed to memory. It's not a matter of smart or dumb here at all. It's a matter of getting it committed to memory. So, okay. I want to look at one more. Let's go down and look at the bottom one. Is that okay? And I am looking at it because it is kind of the scarier one. So let's go down and look at this bottom graph here. Yes. So I'm skipping over the middle one and looking at the third one. And do you see why I want to look at it?
We're just looking at it, right?
We're going to do a little more than look at it. We're going to actually complete it. Okay, so let's look at this first one. Y less than negative 3, absolute value x plus 3, plus 1. So again, what does your brain have to connect? What kind of graph is this? It's a V, yes?
V.
I see absolute value. I know that there's going to be a V involved. Now, what are the pieces in this equation telling me to do with the V? Okay. The plus 3 in the parentheses, left to right opposite the sign, so that's a left 3. The plus 1 at the end is up or down with the sign, which is an up 1. Could you always pull out your gold sheets from last chapter if you needed those?
Yes.
Yes. If you don't have this memorized, pull them out. And then that negative 3 out front.
Stretch it.
Okay. It acts as our slope, which is what I heard over here. Officially, a 3 is going to stretch it, and the negative is going to flip it upside down. Okay. For the purposes of graphing, can we just think in terms of slope of negative 3? We can. So, I'm going to write that real quick, and then we can graph it. So we shift left 3, up 1, and we have a slope of negative 3, which negative 3 is a fraction. Negative 3 over 1. And we already talked about that means this V is going to end up upside down. Okay. So my vertex would normally be at 0, 0. But you're going left 3, down 1. That is a really good question. Okay. Valid point. Mistake. Cost. Thank you. Left 3, up 1. Is that correct?
Yes.
Okay. Yes. Don't let me get away with those mistakes. Now, normally our slope would be up 1 over 1, up 1 over 1, so on and so forth. But if we have that negative 3 out front, how do you do a slope of negative 3 over 1? Down 3.
Now wait.
Right 1.
Wouldn't it be though? Because if it's the negative, couldn't it be reflected over the x-axis?
It is a reflection over the x-axis, but it would be reflected. Officially, if we were doing this transformation by transformation instead of thinking slope, we would reflect it before we do our movements. So officially, we would reflect it. Just put it on there, push down, and there you go. Got it. Okay. Officially, if we're doing this in order of transformations, we would flip it, we would do our reflection, and then move it the left 3 up 1. So that would make it upside down and then still moving that vertex. Okay? Because officially, I guess I should say reflect it and stretch it. And then moving that V. Because are you concerned with how my V ends up instead of down?
No, just why the starting point is still on the positive side of the x-axis.
Because of the translation of up 1.
Oh, okay.
The translation of up 1. Because officially, if we were doing this transformation on transformation, we'd reflect it, we'd stretch it, and then we would move it left 3 up 1. That's the official order of transformations. Now, our shortcuts, though, is we go ahead and move that vertex and then just do our slope. Does that make sense? Okay. So, and if I go down 3, right 1 again, which side of the V is that? That is the right side of the V. So how do you get the left side of the V?
Do the opposite.
You kind of do the opposite, reflect it. So like this one was over 1 from here, you can put over 1 here. Or down 3, left 1. Down 3, left 1. Okay, what kind of V are you doing? A dashed or dotted V? Because it is not equal to. And what kind of shading are you doing here? It's a less than symbol, so it's below. Where is shading below in this case? In the V. Is your shading always going to be in your V? No. Okay. And the other part of this graph. X plus y plus 5 greater than or equal to 0. What do I need to do if you haven't already? Kendra? Yeah, we got to get this y by itself. So, subtract x, subtract 5. And why did we subtract x and subtract 5 instead of just moving y? Because then the y becomes negative. But we can't have a negative y. We would still have to do another step. So, y greater than or equal to negative x minus 5. So, 1, 2, 3, 4, down 5. Then what's this slope look like? Down 1, right 1? Have you got to the point, do you know what a negative slope is going to look like? Because that's helpful, because you can kind of catch your own mistakes, can't you? So I can go down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1. What kind of line am I drawing? Of course, straight line, but a solid line. This was greater than or equal to, so where's my shading? Above. Good. Important final question. Where is that shading? Okay. I'll take that description. The top of the Christmas tree.
Good job, Carter. I heard somebody over there say.
Okay. So in that little section right there, yes?
It's like that little.
Okay.
That's where the stars go.
The Christmas tree star. It's just not star shaped. Okay, guys. For tomorrow, it's lesson 3.3 in Math Excel. If you didn't get 3.1 done, make sure you go back and get that finished up. We are down to just under 2 weeks in this 9 weeks, so we need to get grades in the right position. You will have one more quiz, but we've also had one other quiz and 2 tests, so that quiz will be minimal effect there.
Oh, Thursday.
What is it? It's like,
Why is everyone
is it
saying
math?
Well, that's your fault, man. I'll her call.